All right, this is a mini lecture note number 1. I would like to go over a few things that help you complete the first problem set. All right, so let's look at the first one. All right, we know what percentages is, right? So when we say 1%, per means out of, and the cent means 100, like centuries, right? So 1% just means 1 over 100. So when you say 3% is 3 over 100. So it's 0.03, right? And the next one is popular formulas. Sorry about the name. I didn't have any clever names. But these formulas happens quite often. So it's probably nice to recognize these formulas. So when you have quantity a plus b squared, and you can FOIL it, but it's going to come out to be a squared plus 2ab plus b squared. I'm pretty sure you have seen that. And if the sign's negative, if you have quantity a minus b squared, only difference is that you have a negative sign in front of the second term, 2ab. Right? And next one shows up quite often too. When you multiply quantity a minus b by a plus b, then you will get a squared minus b squared. And you should be able to go back and forth, right? So if you see this, you can factor it out as a minus b times a plus b. All right, so make sure that you can recognize those. All right, then this is a refresher for exponential laws. All right, when you multiply two exponential expressions with the same base, right? So multiplication, then you can consolidate it as a single exponential expression with the same base, but you would have to add powers. So if you have a multiplication between exponential expressions with the same base, then it becomes addition between powers, right? And you can see that b to the x is basically you have xb's multiplied together, and the b to the y is yb's multiplied together. So the total number is, of course, x plus y, right? And the next one is very similar. If you have a division, b to the x over b to the y, then you do b to the x minus y, because you can cancel out some of the b's, I mean the y b's, so you have y less b's than the x b's. All right? Next one, if you have b to the x and raise the whole thing to the y, right? So you have a y set of xb's, the total number of b's, so each one has x, and you have y sets of those. So the total number of b's would be x times y. So you have b to the xy. All right, and the next one is a little bit different. If you have different bases but the same power. So what you can do is, since we have the same powers, same number of factors, we can actually go ahead and multiply a and b first. And then you have, since we know that each of them, we have x of those, so you raise it to the x power. And the same thing happens with the division if you have different bases but you have the same powers. So you can go ahead and do the division first and raise the whole division to the x power, right? So those are the exponential laws, right? And the next one is another simple one, distance. Remember that the distance is simply speed times time. And if you want to find the speed, you do distance divided by time to get your speed. But if you want time, you can do distance divided by speed. All right, get you the speed. All right. All right. Next one is the major one, is a probability. All right. So I'm gonna explain what the probability is, and then maybe go through one simple example. All right, let's talk about probability of an event, E, right? So probability, first property of probability is always between 0 and 1, right? So 0 meaning never happens, 1 meaning always happens, right? And in order to find a probability, this is how we find it. So probability of event E, whatever the event is, we count the number of outcomes in the event divided by count the number of all possible outcomes. Right? I'll go over an example so that it becomes clear. And here, this is a probability of the opposite of the event that's called the complement. So probability of the complement of the event E, all you have to do is 1 minus probability of the original event that we don't want to happen. All right? Here, so let's look at a simple example. Right? So here's an experiment. Experiment is rolling a die twice. Right? Roll the die once and roll the die twice. Right? Second time. All right. Then the first question. Find the probability of getting even numbers on both rolls. So you get an even number and an even number again. All right. So here's the notation. I'm going to use S. This is called a universal set. This is the set of all possible outcomes. All right. And E, in this case, the event to get even numbers on both rolls. All right. So let's find the probability of getting even numbers on both rolls. All right. So first question. So first, we need to find the number of all possible events outcomes. Right. So we are trying to find the number of. So this is a notation of number of outcomes in the S is the all possible outcomes. All right. So to find that, so rolling a die, so on the first roll, you have 6 possibilities, 1 through 6, right? And you have the same 6 possibility for the second roll. So you would have to do 6 times 6 to find the total number of outcomes. So 6 times 6 is 36. So we got that. All right, so all we need is a number of outcomes in this particular event, so getting even numbers both rolls. All right, so this is just as easy, right? So if you want to find the number of outcomes in the event E, then what you need to do is, let's see, first you have to get the even number. So there are only 3 even numbers, right? 2, 4, and 6. So you have 3 possibilities, and you have the same thing on the second roll, so it's going to be 3 times 3. We'll get you there, so which is going to be, of course, 6. So 9, all right? All right, so if you want to find a probability, it's going to be a number of elements in E divided by number of elements in S. So if you want to find the probability, all you have to do is just that. Oops, sorry. Here. Right? All you have to do is that. All right. Then, so we know that number of number of elements in E is 9, and the number of elements in S is 36. So we get 9 out of 36, right? Which simplifies to be a quarter, right? Right. So we have that. All right. So that is the probability of rolling a die, rolling an even number on both rolls. All right. Hi, just a quick, another quick question would be, what would be the probability of not getting even numbers, right? So it's the opposite of the event. So we're going to use a complement. So notation is E, and then you have a C power almost. All right, so this is a complement of this event. All right, so in order to find a probability, all you have to do is subtract the probability of the original event from 1, because that's everything else. So 1 is the entire thing, 100%, you're subtracting the probability of getting even numbers on both rows, right? So if you want to find that, so we're looking for the probability of E complement, right? So we know that the formula is 1 minus, probability of the event. And we found the probability of the event E is a quarter. So it's a 1 minus 1 quarter. Sorry, maybe we can, so here and maybe here. And then, of course, 1 minus 1 quarter. 1 is 4 over 4 minus 1 over 4 is 3 over 4. I got small, so maybe I'll make it a little bit bigger here. All right. All right, so this is the probability of not getting even numbers on both rows. All right, it could be both odd numbers, or one of them is at least odd numbers. All right, so that is the probability. Right, probability of an event. Right. That's it. I hope that this was clear.